multiple passes is going around, come in a little bit, go around, come in a little bit, go around, just like you did with your 203 block, your bench block.
Okay.
Which one you think's more beneficial for the tool in respects to increasing the life expectancy of the tool?
Top.
Multiple pass. So I like multiple pass a lot. Plus, the finish. Look at this. The finish here, if the tip of the tool is worn a little bit, you're going to get a little serration going on there. Whereas if you do multiple pass, you're at full depth. As long as you have a nice tool, you're going to get a nice cut all the way around. You can get a nicer finish this way too. So I click on multiple pass here. You notice a little red turned off button right there. So what I'm going to do is turn it on by clicking this square in the upper left.
Multiple pass.
Mm-hmm. And let's go back and peek at our drawing a little bit real quick. What is this? 2 like about a 1/4 inch of material. Extra material, a 1/4 inch. So that's an 1/8 of an inch all the way around. Okay. So just for the activity of it, I'm going to say let's make this is the distance of passes. Why don't we do
The spacing?
the spacing? Yeah, spacing's the how much each pass takes off, and let's try. Let's try it. Oops, not that much. Let's try 25 thousandths. So if it's an 1/8 of an inch, how many times do we have to go around it? Now you're where I was a minute ago. 5. Okay. And maybe we want to have one finished pass at 5 thousandths. What's spring pass? What's a spring pass?
Running the exact same path again.
Yeah. When you make a cut, there is technically a little bit of tool pressure there on a fresh cut. So oftentimes guys will make a pass one more time around without changing anything, and that's called a spring pass.
And you want me, how many to put there?
Well, I'm just going to leave it 0. I just wanted to talk about it. Okay, so a spring pass. You rough out your part, you make one finish cut, and maybe there's just a little angel hair you want to take off of it to nudge it right into position, be very premium. We might say, let's do a spring pass, and that's where we can put in, we could put in a spring pass if we wanted to. I'll leave it out for now. Couple other things down in this area where that's handy is keep the tool down. This selection right here, keep the tool down. The difference with that is your first tool path, the tool is going to go down to cut depth and go around the part, and when it comes off the part, it's going to want to come up and go down again. So this up and down again is non-value additive. It's not doing anything. It's just cycling the machine. So if we keep the tool down, it'll come off, reposition, and so it's a tighter movement. It's a more efficient movement. Okay, so that's what keep the tool down is about right here. Now we're going to go, since we're doing multiple passes, we're going to go back up to this lead in, lead out item here that I skipped over. Click on lead in, lead out. Now this is split into 2 columns. It's kind of a messy, busy screen. But you essentially have lead in on the left and lead out on the right. Here's a little blue picture of what's going on. You're leading into the part, and you're leading off. You see this little flat line right in between the two arcs? This is your overlap. Overlap up here in the far right-hand corner, I typically put 30 thousandths, just to give it a little overlap. And what we're trying to do is reduce witness marks on our part when the tool engages and disengages. Good. So that's a little right up here in the top. I want to put 30 up there. If this is very big, the downside of keeping the tool down is that it retains its feed motion. So if I have a huge arc or a huge radius basically here and a huge lead in here, it's going to increase its travel time. So what I want to do is try to choke up on these a little bit. So on the sweep, I might do 15 degrees. On the radius, I might choke up on it and do a 0.2. And then on the length, I might go, let's try 30 thousandths, and let's going to see how this looks here. Once we get these upper two set, these two buttons here will transfer all the data to the other column, or back and forth. So I'm going to choose this top button to the right, and notice all these numbers on the right match now. Keep it symmetrical so you can kind of keep track of it. Sometimes you'll have to do something that's non-symmetrical, depending on the part and obstacles, but typically you'll run symmetrical just for the, look for patterns. When you see something that's not a pattern, then you can see a problem.
Tangent also, do the 6, 3, 40, okay, 2, 15.
A little further down here, if we had to adjust the length of the contour, we had to shorten up on it or make it longer, so we get a run at the part, we would adjust it down here. We can lengthen, we can extend or shorten the start or the end. Everybody on that so far? I'm going to click over to the next one, linking parameters. And I'm going to turn on the very top one. Make sure all these are absolute. And I'm going to fill them in. I'm going to start at the top. We use 1 inch above our part for clearance. We use 0.2 for a retract and a feed. Top of stock is 0. And we're going to go down to, and we'll pick up my drawing again. So I'm going to modify this number. Typically, if this was a customer's part and you were programming it, you would want to cut at least probably a little bit more than 1.25 inches. What does that mean about your tools, though? The flute length. The flute length is the amount you can cut per depth pass. Since we're making 1 depth of pass cut, we'd have to have a tool that had 1.25 inches, hopefully 1 3/8 flute length. If we didn't, and we wanted to achieve this, we'd have to also use step down cuts along with our multiple passes. But to keep it kind of simple for now, I'm going to change this to, I'm going to just go what do we want to say? We'll call it 0.75, how about that? So here at depth, I'm going to go minus 0.75.
Did we set up our contour at the top of the part? Or at the bottom of the part?
My box is at the top. If your box is at the bottom, it will come out properly if you make sure these linking parameter numbers are set like they are here.
Well, when you want the depth to be,
Top of part 0, isn't it?
wouldn't you want the depth to be more than 1.25 inch?
Technically, that's what we were just talking about. So in the real world, we'd go past the depth so that when we flipped it over, all we have to do is cut off the excess.
Right.
But because this environment, and this is a learning lesson, what we're gonna do is, because our tools are short, and to keep it simple, we're just gonna modify that depth of cut to 3/4 of an inch.
And then
Most
flip it
of our-
around and do the rest.
Huh?
Then flip off.
But we won't worry about the rest,
Oh, okay.
okay? We just won't worry, we're just gonna modify our drawings. And we could go full depth, but it's gonna make the program a little bit more complicated, and so just to kind of keep it simple and get some basics for now, we're just doing multiple passes. And if you know that if you had to take it full depth, you would probably do multiple passes with multiple depth of cuts. And if it was a critical dimension, you may even, here's your flutes, you may even grind a relief on your tool at if your flutes ended here, you would grind a relief just slightly below that, so you would ensure a complete cut. And then your depth of cut changes would be determined by this distance. So if it was a 1/2 inch, maybe we do 400 thousandths depth of cut steps until we got the whole thing covered. Alright? That's a little bit kind of next chapter stuff, if you kind of understand that. So we're trying to get a grasp of some foundational basics to get you started, so that you're not lost out in the woods with no direction if you ever get a chance to sit down in front of Mastercam out in the shop somewhere.
Yeah, I was just thinking in my head,
Yeah.
like taking the Mastercam course with Mastercam.
Yeah, Mastercam University has a program where they can actually award you a certificate for programming if you go through all their, and then you
Well, I'm
actually.
thinking there's just so many boxes,
Mm-hmm.
and there's just so many. Like I said, if you get lost, I can get lost in here